Good morning. I am Dr. A. Kalai Selvi. Today I present the topic partitioning clustering. First of all, cluster analysis. The process of grouping a set of physical or abstract objects into classes of similar object is called clustering. A cluster is a collection of data objects that are similar to one another within the same cluster and are dissimilar to the object in other clusters. A cluster of data objects can be treated collectively as one group and so may be considered as a form of data compression. Cluster analysis tools based on k-means, k-medoid, and several methods have also been built into many statistical analysis software packages or systems such as S+, SPSS, and SAS. Partitioning method. A partitioning method constructs k partitions of the data, where each partition represents a cluster and k less than or equal to n. That is, if it classifies the data into k groups, totally n objects, that is classified into k groups, which together satisfy the following requirements. Each group must contain at least one object, and each object must belong to exactly one group. A partitioning method creates an initial partitioning. It then uses an iterative relocation technique that attempts to improve the partitioning by moving objects from one group to another. The general criterion of a good partitioning is that objects in the same cluster are close or related to each other, whereas objects of different clusters are far apart or very different. The most well-known and commonly used partitioning methods are the k-mean methods and k-medoid method. K-mean methods. First, it randomly selects k of the objects, each of which initially represent a cluster, mean or center. For each of the remaining objects, an object is assigned to the cluster to which it is the most similar based on the distance between the object and the cluster mean. It then computes the new mean for each cluster. The process iterates until the criterion function coverages. Then the next one is k-medoid method. The k-means method is sensitive to outliers because an object with an extremely large value may substantially distort the distribution of data. The effect is particularly exploited due to the use of the square error function. Instead of taking the mean value of the object in a cluster as a reference point, we can pick actually object to represent the cluster using one representative object per cluster. Each remaining object is clustered with the representative object to which it is the most similar. The partitioning method is then performed based on the principle of minimizing the sum of the dissimilarities between each object and its corresponding reference point. The following four cases are examined for each of the non-representative objects. Case 1. Currently belong to a representative object OJ. If OJ is replaced by a random as a representative object and P is close to one of the other representative object, that is OI, then P is reassigned to OI. Case 2. P currently belongs to representative object OJ. If OJ is replaced by O random as a representative object and P is closest to O random, then P is reassigned to O random. Case 3. P currently belongs to representative object Y. I is not equal to J. If OJ is replaced by O random as a representative object and P is still close to Y, then assign does not change. Case 4. P currently belongs to representative object Y. I not equal to J. If OJ is replaced by O random as a representative object and P is closest to O random, then P is reassigned to O random. Thank you.